Welcome everybody. Thanks for joining us today on this ATSE seminar, Making the Cut, Emerging Technologies Required for Net Zero. As we gather for this meeting from different places around Australia, I'd first like to acknowledge the traditional custodians of the lands from which we meet. And I'm joining you today from Cammeraygal land. I pay respects to elders, past and present, and to any Aboriginal and Torres Strait Islander people who join us online today. As we share and discuss our own knowledge and practices, we acknowledge the deep knowledge forever embedded in custodianship of country. Before we start today, I have some housekeeping points quickly. Please be aware the meeting is being recorded and will be published on the Academy's YouTube channel. And should you have any questions during the webinar, please utilise the Q&A function found in the Zoom ribbon. And also I encourage you to upvote any questions that are there already by liking them. ATSE launched its net zero emissions position statement in September 2021. It calls for Australia to take urgent action to achieve net zero emissions by 2050 at the latest, and for Australia to set a more ambitious interim emissions target for 2030. If widely deployed, mature climate change technologies could deliver a substantial emissions abatement that will be needed to stabilise the climate by 2050. Challenge is that further changes must come from climate technologies that aren't quite ready. That is, technology solutions that have shown small-scale success but are not yet mature, and also those that are still in R&D. These emerging technologies are a critical part of the decarbonisation toolkit required to solve the net zero challenge by balancing sources and sinks of greenhouse gas emissions. A sectoral transition to net zero emissions requires a significant technological transformation. Energy efficiency and renewables are central pillars, but additional emerging technologies will be needed to achieve net zero emissions. Our speakers today will explore the emerging technologies that can be used here in Australia to make deep cuts to our emissions, setting a course for achieving net zero emissions as soon as possible. There are many maturing technologies already playing a part in reducing our fossil fuel reliance, most obviously solar PV, where Australia is a world leader. But what do we need next to make the cuts in our emissions deeper and permanent? I, for one, firmly believe this is also an enormous opportunity for Australia, but I also fear that, again, our intransigence will mean we miss the wave and we will suffer the economic consequences. We have until now been an economic superpower, selling gas and coal to our trading partners around the world. We again have the opportunity to regain that role, but as a renewable energy superpower, transforming our natural resources of sun and wind instead of fossilised plants and animals into the energy that Australia and the rest of the world needs. But we need to invest in the technologies to make this possible. So what are those innovations and technologies that are emerging that we can use to change the way we harvest and transport and use energy in a decarbonised world? So how do we get to net zero by 2050? We have three speakers today sharing their knowledge, experience and insights. Tony Wood will set the scene of developing technologies looking at a sector-based approach. Louise Adams will then discuss infrastructure, focusing on the need for new technologies while leveraging current investments. And finally, Renita Gan, who will home in on specifically on solar PV and look at where we are now and where we are going. So to introduce our first speaker, Mr. Tony Wood, AM, FTSE, who is the Energy Program Director at the Grattan Institute. Tony is a highly regarded Australian energy policy analyst, advisor and commentator. Respected by government, industry and media, he's widely sought for advice on reliable, affordable and sustainable energy supply and use. His successful industry career, including with Boral and Origin Energy, and his many notable external advisory roles, have prepared him admirably as the prestigious Grattan Institute's Energy Program Director. His numerous policy papers, media opinion pieces and public appearances are authoritative. His membership in the Order of Australia attests to the profound respect in which he's held by his peers. Thank you, Tony. Over to you.
Thank you very much, and thank you for ATSE. It's always a pleasure to be involved as a fellow of this organisation. I should have apologised before I start because I've had to escape to a very strange place, and I haven't quite escaped. There's some background drilling noise, so please forgive me. I want to just try and put things in perspective. So I guess the first thing we have to understand really is, where are the challenges? And when you look at this slide, this is just a relatively simple summary of the current position and the outlook for the next decade, the rest of this decade, on where our emissions come from. And what is pretty obvious when you look at it is that emissions from the electricity sector, which have fallen almost 30% over the last 6 years, have been quite dramatic. If you look at the rest of them, sadly, most of them either are going to be flat or increasing. There's some small changes in some small ones like waste. And of course, the most obvious unusual one is the land use changes, the bottom right-hand chart on this montage, which is showing that from about 2005 to a couple of years ago, emissions from that sector were actually falling and went negative, became effectively a carbon sink. But since then, emissions are going up again and are projected to keep doing so. So this creates quite an interesting challenge, because most of our governments and our policies are focused on the electricity sector, and there's very little focus on the other sectors, which is going to be challenging. And the technology challenges that we have to think about vary quite substantially across the sectors and across time, which talks a little bit, we do need to focus on the sectors because an economy-wide carbon price is not going to happen anytime soon for a whole range of political reasons. And secondly, given that, the differential policies that would be necessary probably are at a sector level. The other issue is that there are things we can do now. We know about what they are. They need to be deployed. There are some challenges. There are things and technologies which we know about, but it's still expensive. And there are technologies where we don't know enough. So we can get the next slide, please, Mitch. Okay, so this slide just basically tries to summarize what I've said here. So if you look at the various sectors of our economy, and there's different ways of grouping these. Industry in particular is a bit tricky, because if you break up some of the sectors which are reported under the international way of recording emissions, it doesn't look as though industrial emissions are all that as big as they are, because some of the emissions are recorded against fugitive emissions, some are recorded against stationary energy, and some are recorded against manufacturing. And so it looks a little smaller, whereas in reality, emissions from industrial activity is outside electricity is rapidly approaching and probably will shortly exceed emissions from electricity generation. Now, if you look at each of these sectors, they all have that combination of challenges I've talked about. They all need things to be done now, but what those things are vary quite a lot. So, for example, I'll just quickly go through each of these. Firstly, if you look at transport, the majority, more than 50% of our emissions come from light vehicles. The obvious answer is electrification. We do not have emission standards in this country, and that makes it create somewhat of a barrier. But the developments in electrification of light vehicles are quite rapid and quite significant, and would be expected to accelerate. So deploying those technologies is the answer, and making sure we remove the obstacles to that deployment is the challenge. If you look at the heavy transport side of things, on the other hand, where battery electric vehicles are less likely to be effective, then you're starting to think about things like fuel cell electric vehicles, where they're still quite expensive. Producing hydrogen is still quite expensive, and the focus needs to be on developing the technologies to produce the various pieces of that supply chain, which would contribute. And that includes things like even pilot projects, running trials, and there's already some of that happening in Australia with heavy vehicles. And I'm talking about basically road transport, although it could also apply to long distance rail. And then finally, the more tricky ones, where there's still a lot of research to be done, although we know what some of the possibilities are, is shipping and aviation. Aviation is both of these are a global problem. Shipping, there's a lot of work being done on the possibility of not just going to LNG to actually power the ships, because LNG is still a fossil fuel, but also going to things like ammonia. So that's the technology outlook for transport. Agriculture, there's some really easy ones and some really hard ones. Firstly, there are on-farm things that can be done to reduce emissions. The real challenge here mostly is that farmers are mostly small business people. They are very busy. They don't have the information. And the real challenge is to get the information into the hands of the farmers. And there's things we've recommended on that. But the technologies to reduce emissions on farm are reasonably straightforward for a lot of the emissions. Then you've got some activities which are associated with things like the use of fertilizer and feed for animals. So even the fertilizer companies are working with farmers to try and make that a more efficient process, help them deploy those. Again, the technologies are pretty well known, but the cost of implementing those at the farm level is probably still somewhat of a challenge. And also you've got in some cases, some of the vehicle issues in agriculture are also shared by the more broader transport issue. And then of course you've got the major problem in agriculture, which is burping sheep and cattle. There are technologies being developed in that process, but they're very early stage, and the logistics of getting those technologies going in the field is probably the biggest challenge. Industry, a lot of the activity for the very large number of small emitters that we have in Australia, the answer is electrification, and the deployment of electrification, helping small manufacturers, small businesses change over their capital stock when it's needed is probably the right answer. On the development side, high temperature heating is probably the most important challenge in a way, because almost certainly electrification for many high temperature heating processes won't work. Now, some food processing, mostly electrification will work. There's other challenges there with getting access, switching over from gas boilers to electricity, but it can be done. But high temperature heating is more of a challenge. I think hydrogen would still seem to be the most obvious choice. And there's a lot of work to be done to bring down the cost of how we do that. And this theme of bringing down the cost of hydrogen appears in much of what I'm saying this afternoon. I guess the other one, which is really interesting, and it's more in Australia an opportunity, is the processes associated with extraction of critical metals and their refining. We're talking about everything from copper, nickel, and aluminium, right through to cobalt, cadmium, and all the rare earths. There are a lot of environmental issues associated with those technologies. And of course, if all we do is extract those technologies and process them with high emitting processing technologies, then we haven't really solved the problem. So one of the focuses there is going to be to develop the technologies which we already know about to do that. And there'll be some issues yet to be explored. And then finally, which is the biggest area, is the iron making, alumina, and concrete and cement. There's a cooperative research centre already started around this area. There's a lot of work going on, both at the mostly at the R&D phase. Probably fair to say that there's a combination of research and development in that area. Using hydrogen, something we looked at in one of our reports a couple of years ago, is one way. But there's also things like metal oxide electrolysis and other things that could be applied to a whole range of metal oxide extractions, which may be in the longer term lower emission and more efficient, but we don't know. And then finally, I think cement and concrete remains a fairly significant technical challenge because of the nature of the chemical processes. Again, there's a lot of work being done around the world, but there's no obvious simple answer. Electricity is pretty straightforward up to a point. The first thing is electrification. The solar and wind are going to dominate, not much doubt. We can go a long way with that. We do need to electrify our gas networks, and that is more of a political problem than it is a technical problem. The integration of renewable energy into the grid and the technologies associated with doing that at grid scale and at the local distribution level scale, that's where the technologies are important. It's not so much about the generation technologies themselves, it's about how they integrate to the grid, and there's a lot of work being done in that area. And then finally, you get to what I call plan B for electricity, which is what do we do when we get to the last 5 to 10%? There's a lot of people who will tell you it's straightforward, we just do it with renewables and lots of batteries. I think that's very questionable. And there's a lot of work to be done, I think, to understand how we're going to get to that last 10%, 5 to 10%. And I think Australia even should be realistic to keep an eye on what's going on with small modular nuclear reactors. And then finally, I think this issue of offsets is very important. I know there's been a separate session on that, so I'm not going to concentrate on it, but there's a lot of technology issues associated with measurement and verification. And in the case of direct air capture, fundamental technologies, some of which already exist, the costs are very high. And so then I think I also would group some areas of hydrogen together across all these sectors. We know there's a lot of work going on with electrolyzers. Interestingly, not as much work has been done on hydrogen storage, even understanding where we might have the opportunity for large scale storage in salt caverns or other geological structures in Australia. And even the gas-fired power station that the South Australian government wants to build, one of the big challenges there is going to be the hydrogen storage. So look, I think I'll leave that there. And then that's probably enough for people to who've got an interest to delve into any of the issues in the Q&A.
Sure, there'll be many questions that come out of that. Next up, we have Louise Adams, FTSE, who's the Chief Operating Officer of OBrien. OBrien is an Australian-based design, engineering and advisory company, and as Chief Operating Officer, Louise is responsible for driving the financial, operational and people performance across all areas of the business to achieve the group's strategic business goals. Louise has made an outstanding contribution to the engineering profession and the community through her project work and industry leadership. And she has a passion for organisational diversity and the role it plays in innovation, and is an advocate for female leadership and equality in STEM. Over to you. Thanks, Louise.
Thanks, Catherine, and it's wonderful to join you and the other panellists here today. Hopefully I'm going to complement what Tony said just now and talk a little bit about the importance as we undertake this necessary transition to net zero in ensuring that whilst we look at new technologies and build new assets, that we also specifically challenge ourselves with ensuring that we utilise our existing infrastructure as much as we possibly can. And I feel this is essential because if we think about the mitigation hierarchy for emissions reduction, then absolutely we can't just look at the end game. We need to look at the activity and materials required to get us there and seek to reduce the impact along the way. We often assume that this will result in us avoiding steel making, cement making, manufacturing, construction, transportation, unfortunately, all the things that drive GDP and create jobs. And as Tony has already indicated, that can be pretty overwhelming and a little contradictory in a world powered by growth and progress. So we have to remember that the key to our long-term future is sustainable development. Reducing our emissions footprint on the world and becoming more sustainable is just as much about what we choose not to do as it is about what we are doing differently. And sustainability doesn't need to threaten employment or GDP growth in Australia or in developing companies. Now, I'm going to say out front, I'm not proclaiming to be a subject matter expert in all of this and not at all an expert with the deep knowledge of my peers on the panel, but I am going to advocate that to really lean into this challenge, we need to not only be thinking about new technologies and building new infrastructure, but we need to be keeping one eye on the bigger picture, holistic planning and whole of life mindset, thinking through asset life cycles and value chains and understanding where the capacity for improvement lies along that whole chain. Are we thinking enough about repurposing or upcycling existing assets, about squeezing every last drop of capacity and usefulness out of the sunk cost and indeed sunk emissions that are already embodied in our existing infrastructure across the board? One estimate is that 45% of emissions result from how we extract, use and then dispose of materials, which means energy substitution only gets us so far in reaching that net zero aspiration. How we think about the materials, how they move in our economies, as Tony has said, is going to become increasingly important when it comes to reaching our goals. For example, we talk a lot about reducing emissions by electrifying our transport, our industries and other areas of our economy. And we know that it's certainly one pathway to reducing emissions, creating regional jobs and becoming a clean export superpower, but it does come with its own costs if we achieve it simply by building out significant new renewable energy generation, as well as the transmission needed to move it around. I'm not saying that these new technologies and new infrastructure aren't needed. I'm just saying that in and amongst all of that, we need to turn our minds to opportunities to make better use of what we already have. So one example, which is an existing technology, is the Waratah super battery that was announced for New South Wales this past month. That's a good example. So whilst it has a couple of hours of capacity at full power, that's all it needs to be able to prop up transmission capacity in the grid during congestion periods, which would otherwise see restrictions in power flows between generators and consumers. The Waratah is a capacity enabler that frees up reserve capacity in the transmission network that would otherwise go underutilised. So it means more low-cost, zero-emissions renewable energy that can be moved around the grid without building wind and solar and without building more poles and wires. So it is a fantastic example of doing more with less. Autonomous vehicles are another capacity enabling technology, and it's an existing technology, I know, but self-driving cars, as we get more and more of them, they can actually significantly ease congestion in our existing road networks. Current modelling shows that road traffic with a high fraction of AVs can increase peak traffic flows to the order of 20–25% just by the shortened headway and stopping time requirements. So with increasing AVs on the road, we are getting greater road network capacity without building new roads. And AVs can reduce energy consumption in other ways. Autonomous freight trucks can platoon together, slipstream off each other, reducing drag and improving energy efficiency, again, with no need to go and build new infrastructure. So for me, this is part of the technology challenge we need to lean into, alongside our efforts to harness new technologies and new opportunities. We also must put some of our innovative effort to how do we transform what we already have. As we move towards a net zero world, is there scope to repurpose existing pipelines to transport hydrogen or carbon dioxide instead of natural gas? Can we repurpose existing infrastructure easements and transport corridors that we then find we no longer need to minimise clearing and excavation? And for the next generation of infrastructure that does need to be built, can we build carbon sinks by using materials such as sustainably forested timber or advanced concrete that sequesters atmospheric carbon? Can we design with that end in mind, making the materials themselves able to be readily repurposed or recycled at the end of their life? I think about aluminium. 75% of aluminium that's ever been produced is still in use today as a result of recycling. So why can't that be true for all of our materials? We're now regularly in the habit of reusing water bottles instead of buying new ones over and over again. So, you know, can we put these same mindsets to how we treat our infrastructure? We can already design buildings and other infrastructure today to better enable their materials to be salvaged and scavenged for use in the following generation. So how do we incentivise the design of things that we do today in this transition for reuse at their end of life, making sure that those carbon absorbing and recycled materials will displace the high emitting or virgin materials that would otherwise have been used in the next build? So it very much aligns with a circular economy narrative. And whilst we're transitioning, how can we do it in a way that reduces our net impact and minimises the social disruption and inequity that has come with the tectonic economic shifts that we've seen in the past? So to make better use of what we have, we need to know what we have. And so there's a clear role for digital technologies and approaches, and continuing to challenge ourselves on how we create digital technology that can give us the right data so that we can make sure that our infrastructure is as efficient as it can. And certainly being able to access the right data in the right way can play a huge role in making the key decisions we need to make along the way. So technologies don't just need to be about new things. We can harness them to be more efficient with what we have. We can reduce our emissions intensity by reducing our material intensity. And similar to what Catherine alluded to in her acknowledgement of country, we should also challenge where we look to for ideas. Throughout history, I do believe we have a habit of looking past the Indigenous custodians of our land. And when it comes to climate change and the challenges that it brings, our approach can sometimes be no different. And ironically, we seem to be captivated on the idea that high-tech solutions are required to solve a problem that arguably was caused by our captivation with high-tech and industrialisation in the first place. So if we learned anything from the natural disasters that have hit Australia these past few years, then surely it is that our ability to manage the conservation of country, that habitat that existed way beyond our lifetimes, is as critical to our survival as what we do in our cities or in our individual homes. Getting to net zero will require a lot of new stuff, and there's a litany of amazing technologies available to support us on this journey, but we need to be smart and think about the end game. As technologists, scientists, engineers and designers, we need to give more breathing room to the idea that when it comes to our net zero journey, sometimes the best new build may just be zero new build. So Catherine, I'll pause there, and hopefully some thought-provoking insights, and I'm super keen to hear from Renata as our next speaker. So I'll pass back to you there.
Yes, many thought-provoking comments there, and I'd quite like to delve into conservation of country. We spend a lot of time talking about putting new trees in, and how about we just stop chopping down some of the current ones, might be a good start. But all of that later when we get to the Q&A session. Thank you, Louise. Next, we're coming to Professor Renita Gan, FTSE. She's Professor at the School of Photovoltaics and Renewable Energy Engineering at UNSW. As an innovator, entrepreneur and academic, Renata is passionate about using her skills to increase the uptake of solar and accelerate the energy transition. Recently described as one of 8 great women, that's pretty impressive, in the business of science and solar by Renewable Energy World, she's led manufacturing and industrial technology development of energy technologies in Australia, Germany, and China. Renata currently leads the UNSW activity in the Australian Centre for Advanced Photovoltaics and is a co-founder of successful startup company Solar Analytics. And personally, I know her from her really important role in getting the CRC for reliable, affordable, clean energy by 2030 up. So thank you for that, Renata, and over to you.
So I was saying that we can solve a good part of our problems in electrification by moving to solar, wind and batteries as soon as possible. And the rate at which we are travelling now, we can solve 80% of our problems by 2030. And if we accelerate our current deployment, we can do better than that. At the same time, we can electrify transport and heating for further substantial cuts. We can already see what a low emissions transport future looks like. Our trains and trams have been electric for years, and there's a worldwide transition to electric vehicles taking place, and that's likely to be driven faster by the insecurity and rising oil prices. A growing market will drive innovation, economies of scale, and choice in electric vehicles. Right now, what we need in the transport space is leadership rather than technology change. The next big opportunity beyond electrification of renewable energy for electricity and transport is stationary energy, which is largely heating, and that's sourced through burning gas. This can be addressed, as Tony mentioned, by electrification using more efficient technologies such as heat pumps and reverse cycle air conditioning, and at an industrial scale through electrification and by innovation, including with technologies like concentrating solar thermal. Electrification of transport and heat will double the demand for electricity, which will put pressure back on renewables for deployment and innovation and create further opportunities in zero emissions electricity. The challenge in meeting these deep cuts early is in integration and in infrastructure, as discussed by Louise. We are moving from a centralised to a decentralised system, which requires a reinvention of our networks and markets. Fortunately, there's significant leadership in this space by the market operator, as AEMO, and at a state level. Zero emissions will be different for every nation, reflecting the resources, investments, and stage of development. Australia is extraordinarily well placed to meet its decarbonisation needs from wind, solar, and storage. Other parts of the world will rely more on things like geothermal or nuclear. Some will need to import fuels, such as hydrogen and ammonia, and Australia can have a role to play there. So we expect ongoing innovation in solar, wind and batteries. We need innovation in infrastructure and in integration, and we need every decision that we make from now on to be away from oil, fuel and gas. We have the technologies to address emissions, electricity and transport and heating, and with ambition we can make deep cuts by 2030. And doing so will make the next stage of getting to net zero more achievable. And as demand grows for these technologies, we will continue to develop and improve. Variants will emerge and economies of scale will continue to drive down prices. One of the reasons why solar has been so extraordinarily successful over the last decade is the technology is scalable without a format change. Basically, the cell inside your 20-watt camping phone charger is the same cell used in the 20-megawatt solar farm. There's just 1 million more of them in the solar farm. And the unit cost keeps going down the more we produce. And this is true for batteries in electric vehicles. These technologies will continue to improve, driving down costs and improving efficiencies. Examples of where we're working in these technologies in solar We're working in solar PV, we're working on tandem cell technologies. So 2 cells stacked on top of each other that will deliver us a step change in performance. The work in Australia is being done at the Australian Centre for Advanced Photovoltaics, and it's funded by ARENA. The aim is to improve performance and reduce cost to deliver 30% efficiencies for the solar technologies, up from 20% now. At the same time, we push down the costs. We're working on sustainable growth in line with the issues identified by Louise, and we're working on how to integrate distributed solar better, led by the market operator AMO and by states, by companies like Watt Watchers and Solar Analytics, and with the new CRC for reliable, affordable, clean energy that Catherine mentioned. And we're working on how to deploy solar at a scale faster and more cost effectively. These are led by companies, innovative companies in Australia like 5B and Sun Cable, and in partnership with research at UNSW and ANU. There are ongoing improvements in concentrating solar thermal for direct on-site generation of process heat by CSIRO, by the Australian Solar Thermal Research Institute, and by companies like Vast Solar. To enable more solar, there is enormous innovation going on in battery technology, with different battery chemistries and with thermal, gravitational, and pumped hydro storage to meet the different challenges of long-term and short-term storage demands. With ambition, Australia can move to electrification and renewables and solve the majority of our emissions well before 2050. We should accelerate this transition to put us in the best place to handle the remainder of our emissions and to set ourselves up to be exporters of zero emissions solutions, including green hydrogen, green ammonia, and green steel. While we deploy and innovate to meet the challenge of electricity, transport, and process heat, we can then address the more challenging emissions from other sectors described by Tony in waste, aviation, shipping, and industrial processes and land use. These are responsible for around 20% of our CO2 emissions, or around 100 megatons per annum. Substantial R&D is needed to address these, with options including electrification, alternate processes for iron making, alumina and concrete, and alternate fuels such as hydrogen to replace coking in steel production. And to some extent, we'll rely on carbon sequestration, including innovations in carbon capture in cement production. Carbon capture and storage may have a role in drawing down carbon in the atmosphere in the future, but I don't see it being competitive in combination with fossil fuel use against the low cost for energy generation, that is, against the low cost of energy from wind, solar, storage, and green hydrogen. So in summary, the technologies that will significantly reduce emissions are solar, wind, and batteries, electric vehicles, and efficient electrification of process heat. While considered mature, there is significant innovation in these technologies. Every decision we make from now on needs to be towards these technologies and away from oil, fuel, and gas. And success will require renewal in infrastructure and innovation in integration. Within ambition, we can make deep cuts by 2030, and doing so, we will set ourselves up for the next stage, getting to zero emissions more achievable and with greater national benefits. Thanks.
Thanks, Renata. There's a lot of stuff opened up there as well that you've touched upon. There's not much in the way of Q&A at the moment, so I'm going to have the joy of getting my first questions in, while hopefully the others are thinking about what your 3 talks have provoked in the way of questions. So Louise, I'm going to start with you with what can individuals be doing to make sure we get to net zero as fast as possible? You've spoken about the building of infrastructure, but how do my decisions as an individual influence that?
Yeah, look, I think it's a good question. And I think, you know, we talk a lot about the small individual tweaks that we can all make as consumers in terms of reducing our consumption, doing more with less and being more mindful about where our products come and where our waste goes. And often I think people can trivialize those small decisions, but we know that if everybody was to do it, then aggregated up, they'd have a big impact. I think also really leaning into this piece around choosing organisations like, you know, how do I choose my electricity provider, you know, based on really understanding their level of support for renewable energy projects, and then you know, if we all sort of pivot those decisions more towards the providers that are really vested in that, then that'll create a demand and have an impact. Same thing with things like our super funds. You know, if we start to put pressure on super funds and start to pivot our choices there to those that are providing support to these transitions and things like green infrastructure or green steel, all of these things that we know that there are some big funds pivoting towards, I think that's important. I think specifically for an organisation like this, there's also a role for us to play in helping take what can sometimes be highly technical information and knowledge and translating it into stories and narratives that are really easily digestible for the average person. We know that this the climate change debate and this whole transition to net zero, as you said in the intro, is highly politicised. So getting some clear, easily digestible narratives, even if it's just within our little communities, you know, whether it's the parents that we engage with at the schools or, you know, people that we hang out with at sport on the weekend or whatever, I think we as you know, engineers and technologists and scientists can play a real role in putting a very strong, non-politicised voice to some of this, you know, some of the narrative around what we can individually do and the decisions that we can make and the technologies that we can look into.
Thanks, Louise. And it is a perennial problem of people feeling too overwhelmed and what can I do? And it's really important to get some tips for people to actually be able to feel like they have at least a tiny modicum of control over things. Both Tony and Renata touched on small nuclear reactors, and I often get asked this question about where's their place in this pantheon of new emerging technologies that we should be taking account of. And I wonder if I could pose it to each of you to give some thoughts on that.
It's Renata here. I'm happy to speak to that. I'm hoping that my microphone works for me this time. I think that there is a place for nuclear. There are nations that have already invested and have the technology development and operating plant. It makes a lot of sense for those to continue and to see out their useful life. The large nuclear plants that go in are hindered by the scale and the risk and the expense that goes with them, which is why the technology is moving to small modular reactors, which, as by their what they've described as, the idea is to take the nuclear technology, scale it down so that it is, you reduce the risk, you reduce the expense. It's much easier to deploy because you're dealing with a smaller, manageable challenge. And then you can deploy multiple of them and get the benefits of scale by deploying these modular reactors rather than very large reactors. And there is an awful lot of research and development going on in that space. At the moment, as I understand it, there is no commercially viable small modular reactor available, although the technology you can imagine is very similar to what goes inside a nuclear submarine. And we know that that has a 15 to 20 year build time. So I do think that there's a place for it. I do think the technology is advancing and that the opportunity will grow. I am not convinced that Australia will have a significant need for it, other than to capture perhaps that last little piece where wind, solar and batteries won't work for us. It will not necessarily address the challenge with the last 20%, which is associated with waste and agriculture. It's really just a question of small modular reactors, how they are an option for electricity generation where wind, solar and batteries don't work. Over to you, Tony.
Tony, what do you have to add to that?
Most of what Renata has said, Catherine and I would agree with. The interesting thing is people may have already seen there's a video of the building of the Hinkley 3 power station in the UK. It's available now on SBS, I think. I'm not giving a plug to SBS, but it's interesting because that project is about 30 billion euros. It's taking more than 10 years to build. And the only way it's been financed is for the government to sign a contract on behalf of the consumers of the UK at a wholesale price of electricity, which is about twice the current wholesale price for the next 30 years. Now, that's a big deal, right? And the reason that the small modular reactors are interesting is it's a bit like the solar PV story. If you can make these stuff in a factory and turn them out in a factory rather than just everyone being bespoke, then you've got some possibility of driving down the cost. And serious companies like Rolls-Royce, for example, are absolutely pursuing this alternative. There are some contracts being written, although I think the deployment of the first round of these by companies like NewScale, for example, with this US company, are still 5 to 10 years away, but getting more realistic. I think in Australia, it's interesting because one of the challenges we have with all our solar and wind, which I completely agree is plan A, is building a large amount of transmission infrastructure. And we know from even there was a protest march in the streets of Melbourne yesterday of people protesting against power lines for the connection of solar in their communities. So, it's an example where you've got, two different environmental concerns fighting each other. You wouldn't have that maybe if you had small modular reactors. Now, I think we've got a long way to go before that becomes A, necessary, and B, politically viable. But I do think we should be A, having a good conversation about the circumstances in which it might be applicable in Australia, and secondly, how you would actually do that. There's lots of people thinking about it, but the political challenge is the big one, Catherine.
And if they're protesting about environmental challenges of building power lines, what will the protests be like about talking about small nuclear reactors? I can only imagine. From the floor now, Milad was first in, thanking Renata for your insights. I'm wondering if you've got ideas on how to improve the reliability of the power supply, moving from centralised or decentralised power generation, considering more often natural disasters such as floods, storms and so forth, which of course we're extremely familiar with at the moment in Sydney and the rest of the New South Wales, South Queensland coasts.
Yeah, okay, thank you. Well, I'm not an advocate for off-grid. I think the grid forms a really important function for our reliability of supply, and it keeps our hospitals and our trains and our traffic lights operational. So we're all, I'm not suggesting, I would not at any point suggest everybody should consider to go off grid, but the decentralized generation of electricity, there's rooftop solar, batteries, and small solar farms in regional Australia, as well as the large scale utility farms, actually offer the opportunity for greater resilience because you become less reliant on centralized generation. So there's an opportunity for improved reliability, but there's investments to be made in the interconnection, the integration, and making sure that the pieces of the market all work properly. But their potential there is actually for increased resilience and reliability. These small communities that are disconnected now from centralized generation because of floods and the like would be faster to come back online if they could be isolated themselves. Either the community is isolated or even their homes and businesses are isolated. I actually had a personal experience yesterday in Sydney when a tree took out power lines around the corner from my house, and the entire street was without power. But I've got solar and a battery, and I didn't have a lot of power, but I was actually able to trim back all the consumption in the house so that we kept everything going for 24 hours while the power was reinstalled. So that doesn't actually make sense at the moment financially for most people. I did it because I'm into energy, and I was interested in the learned experience. But my experience yesterday was really positive. We were able to let our neighbours come in and charge their phones off our reliable energy supply, and
to keep the fridge running.
Yep.
Incredibly important to most of us. Thanks for that, Renata. Louise, you talked about the importance of the collection of data. Do you think there should be a greater priority on using emerging technologies like artificial intelligence to do this? That one from Rhiannon.
Yeah, look, I think it is a very good question. And when I think back to the way I worded in my speech, I probably could have used better terminology, because actually a lot of the time these data sets do exist. We just don't know how to actually pull them apart and analyze them and get the insights out of the data. So I think there is a role for artificial intelligence, absolutely. And I was actually talking to somebody the other week. We were talking about the capability constraints that are existing in Australia and also over in New Zealand, which have been amplified off the back of COVID. And they were telling me a story of how one of the companies they were working with were losing their data analysts and their data scientists to with 2 or 3 or 4 years experience to job offers upwards of $600,000 a year. So it certainly is a skill set that's been cried out for. So the answer to that has to be that, you know, the long-term solution has to be able to get more artificial intelligence and to be able to get more, to be able to go through those, what will be reams of data that come out of these assets and analyze them properly. I don't see any other way other than really investing in artificial intelligence to do that for us.
Thanks. I can't believe I only have one question left on this Q&A. I'm quite sure there must be more. I'll go to John's question, and then maybe if there's no others from anyone else, I've got plenty. So John asks, what role do panelists envisage for using EVs as storage devices for supplying electricity back to homes? And I think all three of you might have views on this. So V2H or V2G type of situations. Let's start with Tony.
It's technically possible. I mean, some of the car manufacturers don't like the idea very much. They know some of the cars aren't made for that purpose. I think the answer is going to be, firstly, think very carefully about the way we've mismanaged rooftop solar PV and batteries and feed-in tariffs and all that sort of stuff, because unnecessarily we created an enormous problem because we didn't structure the incentive arrangements to recognise what was going to happen when we had very high levels of rooftop solar. And now we're struggling to fix that. It was fixable in the first place. We shouldn't have got here. And that's what's happened. Now, as a result of that, people, I think, are very suspicious about allowing energy companies or regulators to play around with their house, and their car would be even more difficult. So I think there's some very important social and psychological issues here that are going to have to be fixed. The technical problems, I think, are relatively straightforward. The really interesting technology question, again, is how do you integrate the combinations of demand and supply in that system so that individuals are not having to make individual decisions. I am sure I should be able to come home at night, plug my EV in, and then the system will decide when to charge it. It'll charge it at the best possible time overnight. And if I want to have I need my car in 4 or 5 hours time, I just say, look, I need to have a very sharp charge and I'll pay for that. But we're a long way from that yet. So I think it's going to be the interaction of the technology and smart providers who put these things together with consumers who I think really aren't interested most of the time in most of this stuff, to be honest. We are, but finding the ways to make it less invasive, sounding less like Big Brother is one of the answers here. And there's things we've done in the past to do that, honestly, Catherine, but there's also some very serious lessons to be learned from what we haven't done so well, because we don't want to stuff it up by just implementing it badly. Technology is not the problem.
I think there's an awful lot of consumers out there who don't even know that their inverters are being switched off in the middle of a day when there's an awful lot of sunshine around and way too much being poured into the grid. I suspect that's the case. Renata, what would you like to add to that?
So I temper some of the concern, and I think that's a lot of in how we communicate with people. There is not a lot of inverters being shut off in the middle of the day at the moment, very rarely. It's possible and it happens, but it's not common. And we've got some data that looks into that. It's really on peak Sundays when there's lots of sunshine and it is a mild day and there's not a lot of air conditioning on. For the most part, all of the solar is being consumed. I agree with Tony's comment about the vehicle manufacturers being reluctant. I mean, they build a car for for transport purposes, they don't build it necessarily and design all the electronics and the battery around backing up a home or backing up the grid. I'm imagining a situation where there is a little bit more centralized thinking around it, and things like our buses and trucks, that the very large scale use of batteries in the larger vehicles is a bigger opportunity. And you see that actually in, I think that you're seeing this in the future happening in places like in China, where there's provinces, Guangzhou province is an example, where the entire bus fleet is electrified. And they have a wall of batteries which are exchanged using a forklift in and out of the bus to keep the buses on the road. And the wall of batteries is the grid storage. So while the batteries are being charged, they also offer the grid stability piece. So I can imagine that, like on the sort of the industrial scale, I can see it working. I think on the individual residential scale, I think it's a lot more challenging because of all that independent decision making and the desire for independence and the challenge with the consumer having made the investment in the asset. That's with solar or rooftop solar, with household batteries, and with electric vehicles. The consumer owns it, and you have to really incentivize them to change their positioning on that.
An interesting scale in between those, and some time ago even, Scripps, the university in San Diego, was using a system whereby if people had EVs, they could charge for free in the university car park, on the agreement that at 2 o'clock or thereabouts, when everyone came back from their sunny lunch times and cranked up that air conditioning, that they could actually take the electricity back out with the promise that you'd have a full tank again by the time, or a full battery, by the time you go home. But it was just to smooth out that huge surge that they had found every time people came back from their lunch, and everyone just cranked up the air conditioning to cool themselves down again. So that's, I think, something like 10 years ago now. So it's interesting how that sort of thinking's been around for a while, and not many people have implemented it at that sort of medium scale, not as big as those buses and not as small as a single home, but potentially one where it could be really valuable. Louise, do you have any other comments on that from I don't know, infrastructure and those kind of areas, or the AI to do it?
Well, I think, as both Tony and Renata have said, that it really isn't a technology issue. I think I'd go back to what Tony said from an infrastructure perspective. It really goes to that whole of life thinking. So let's imagine a world where we had massive uptake. If it were an option and we had a massive uptake of it, then what would we not get in terms of tariffs and, to still manage and pay for and control our central infrastructure, and have that sort of thinking up front to say, to Tony's point, so we don't make mistakes in the core decisions, the policy decisions, the legislative decisions that we need to make for that potential end game. So I think it really supports that idea that we need to imagine what might it look like with high uptake, and therefore what are the decisions we need, how do we frame it so that the community has all that information up front and knows what to expect.
Thanks. And we had one more question, which I think we've pretty well covered, but there might just be a little bit more in it, and we've only got a couple of minutes left, but asking about any issues that need to be addressed for consumers to have a confidence in the AI and their home being controlled. And I think you've pretty well covered that, both Tony and Renata, really. But is there anything else that you want to add from a consumer point of view as to how we can educate them if this is coming, how to be comfortable and secure with it?
We know how to do this, Catherine. We've done it in Brisbane, for example. The electricity company already does it on a routine basis. It was well communicated to consumers that we're going to have direct load control over things like pool pumps and those sort of things. It works fine, but it was well communicated. Whereas a few years ago in South Australia, some years ago now, when they talked about doing that, the community, it was become a political problem, Big Brother interfering in your house, and people hated it. It's exactly the same thing, but it was the way it was put together and the way people were brought along on the journey, understood what was going to happen, and then willingly signed up to it. So we know how to do this, but we also know how not to do it.
I think a lot of what we've got coming is all about communications, isn't it? In every aspect, whether it's small nuclear reactors or just having someone else control aspects of your home energy situation. So thank you, everybody. I think we better wrap it up there. Thank you so much to those that have listened. I know it looks like a small audience, but I know there'll be hundreds more looking at this as a later broadcast on YouTube. So please do share with any of your colleagues and friends that this has been interesting, and make sure they go along to the YouTube channel to have a look at it. The next talk will be focused on technology deployment, lowering emission while creating opportunities, and that is scheduled for the 12th of April. So I hope to see some of you there as well. Thank you everyone for attending. Thank you so much, and particularly, of course, to our panelists for generously sharing their insights with us today. And I'll look forward to seeing you all again soon. Thank you. Bye.